Hello everyone, I'm going to show you how to use PICO, how to add the symbol to PICO symbol to KiCAD, and how to build a simple project using PICO board we are going to use in our class. So I have prepared my PICO, I prepared some components, and we are going to build our circuit in a minute. But before starting any work on actual project, it's always important to have a good plan, and that plan we are expressing in form of schematic diagram. For schematic diagram, we are going to use KiCAD, and KiCAD will be our main tool for this work. So I'm returning to KiCAD, and I'm opening the schematic editor for our project. So it's empty, nothing is there, and we will prepare we are going to prepare our page first. So that will be portrait orientation. We are typing here, we are selecting letter size. We are going to use today's date. Title is project 01. Company is FIO. We are typing here our name, your name, and I'm typing here class. Okay, we have a title block populated with the your information, and we can start adding component. Unfortunately, PICO symbol is not available in default version of KiCAD, so we need to add symbol, and we are going to tools, actually preferences, manage symbol library, preferences, manage symbol library, and we are going to add existing library to table. Existing library to table. Navigate to the folder you downloaded your KiCAD symbol for. Symbol for your PICO. I have it here. I'm going to add it. Okay, and we have a symbol added to the library. So now, once you add it, you don't need to do it every time you are using KiCAD. That must be done only once before you are beginning your work. Now we can click to the symbol, and if I type here PICO, I will have that symbol of our Raspberry PICO on our board. So I can click and place it on our paper. So that is our first symbol. Second, as I mentioned, we need in assignment we need to place few additional symbols. We have a switch, so I'm clicking here, switch, where RSV MPC 5E. That is our switch. There are other switches, but that is actually our switch. Okay, I'm placing that switch somewhere on next to our PICO. Next step is to place LED. 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 I have a LED. I will place that default LED somewhere. So I need to rotate it. I'm pushing R bottom. R is to rotate, or you can do it through menu. Here is R is rotate. Then we are placing resistor R US American resistor. We are placing American resistor here, and then we have 4 capacitors, electrolyte capacitors. C, again we are going to use American system, US, C polarized US. That is the symbol for capacitor. We can change the value of that capacitor right away. I'm clicking edit properties. That is 10 microfarad there is no Greek symbol micro here, but that is 10 microfarad. So I can Control C, Control V, place them in parallel. Control V, Control V is 4th symbol in parallel. So now I can do all the connection. I'm using wire, add wire, and I am going to use 3.3 volts power from my PICO board. I'll slightly move that one down to align with 3.3 to reduce our work. 3.3 to 1, then to my diode, to resistor, and to series of capacitors. Capacitors. Close that circuit. Something is wrong here. Delete. And we are going to use a ground from the board, so we will use that ground for the ground for our system. And generally this is everything, except I need to change value of my resistor. Again, right click on mouse, properties, and at the beginning, okay, that is var1. I can write that 100 kilo ohm, 100k. That is my final resistor in this project. Good. This is the diagram. and we're supposed to be able to make that project quite easy. So I'm going to save it, and we can of course export it to Word by pushing, selecting file, export, drawing to clipboard. That's how we are exporting our project, our work to Word, and then we are selecting Word. Of course, that is not this file. File, new Word, and I can paste my entire diagram to the Word. So what we can do in Word, again, still there are some borders. We can reduce those borders by clipping them, but that is, it's up to you. But try to make it full page, otherwise it will be very difficult to read that report. Okay, we have our breadboard with PICO, and we have our schematic diagram here on the screen. We can start building our circuit. First of all, power supply. We have plugged the power supply. Like this. Then we have a few items here. Ground, which is pin 3, goes to the blue rail. It's more convenient. Then we have a plus 3 volt, 3 and 3, which is 5th pin from the top. Go right there, and we can check if our circuit works, if it's power. It's getting powered by using a resistor and diode. LED diode goes to long leg, goes to the ground. Short leg, long leg goes to the short leg goes to the ground. Long leg is getting plugged somewhere onto breadboard, and we are making connection between 5 volt and the long leg of our LED. And if everything is powered, we are getting emission from our LED. So our circuit works. So we have some voltage there, and we can try to build something a little bit more complex. Okay. Next step will be to install the switch. I'm plugging the switch across the valley here on the center, somewhere here. Switch is plugged in, and we are going along our circuit. So we are right now here. We need to connect 3.3 volt to our switch. So 3.3 volt from the board goes to the switch. Then we need from switch must go to our switch must go to diode positive terminal of our diode must go to the switch, so we can plug it directly here. And then our resistor is connected between the LED and ground, so we can do it like this. So my diode is connected to this through the resistor to the ground, so we can check if that part of the circuit is functioning. So we are debugging it slowly. So that part works. Disconnecting the power and keep adding. So we have to, I suggest to use 4 capacitors. I'm going to show you only 2 of them, but its work is same. So I am plugging capacitors into the board. So short leg of the capacitor is negative, goes to the ground, and I'm plugging it like this. We can do it, okay. Since all of them are in parallel, we can do it slightly different. I will do the across the wires, one resistor, one capacitor, second capacitor, we can add more capacitors. Add fourth capacitor, third capacitor, and fourth capacitor. So all those capacitors are in parallel right now. So what we need to do, we need to connect them to the rest of the circuit. So negative part of all those capacitors, all the electrolyte capacitors, are sitting on one wire. That negative must go to the ground, and positive must go to our switch, the same point. And seems that everything installed correctly. I am plugging my power. Arduino works, and Raspberry Pi works. My light is shining and then slowly decay after I am releasing the switch. Thank you for attention. Please prepare your report and submit in timely manner.